The surface of the Sun at any time is covered with millions of tiny plasma jets.
Could paint jets on a subwoofer provide insights into the solar spicule forest?
Both kinds of jets rise and fall under gravity, though there are differences. Chromospheric plasma experiences acceleration several times the gravity on the solar surface.
Free surface Faraday oscillations of a fluid result in mesmerizing patterns and jets for large accelerations in terms of Earth's gravity. One could observe such phenomena in nature, such as male alligators bellowing to attract mates. A lot of splashing. Is it because water is too thin? Adding a tiny bit of polymer in water, we notice that the jets do not break, whereas lots of droplets are seen over a similarly viscous glycerin solution that lacks these long-chain polymers. These base solar surface rumblings could be used to excite fluids. The polymer chains inside can be thought of as coiled springs, which bestows elastic properties to the viscous solution. The signatures of these extensions could be seen.
Analogously, the solar plasma can be imagined as strewn by magnetic field lines, along which the ionized gas flows. They are stressed like the taut strings of a guitar, but when snapped, they have to reconnect. This aids the jet formation. The magnetic field in the plasma and the polymer chains in fluid make the respective systems anisotropic. In the absence of magnetic fields in the solar atmosphere, this is how the plasma would behave under Faraday-like excitation. The similarities allow us to perform parallel harmonic excitation experiments on both the systems to obtain a forest of jets and further study the phenomenological, physical, and mathematical similarities.